There's that line, that's at the 11th. And then I need 512,
You can add, so there's 8,
so I put the line
and
there.
then 9, 10, 11, right? So then what's this? That's 8.
What do you mean?
These would all be zeros in the host field. So that's only 8 when you do the binary on it.
So here is where I did the host. This is
supposed to be a 0 though. Why'd you put a 1 back in there? This is the first number.
because I did them from here.
Here's the
Yeah,
last two
you're not supposed to do
octets.
that. You're supposed to take it from the first one.
Okay.
From the 21,
Okay,
which is
that's
11.
what I was trying to ask
Yeah.
earlier.
Yeah.
Okay,
Remember when I
hold
said,
up,
how
hold
do you
up.
find the initial?
Yeah.
Here's the IP address, the last two octets. There's the mask. I've done nothing except skip the first two octets because those are all ones there. It's the octet where the ones and zeros separate, right? That really matters.
Well, what's going on, and I think I made this mistake early on too, is breaking it up for so the first one, you need 9 host bits. And you're taking that for the network instead of the 11 from the 21. That's what's going on.
This is the explanation of what we start with. You're talking about the first network.
Right, that's
And
what
you could get that same number.
that's what we were talking about earlier. Remember I said, can you just do it from here, divide the networks, and you said you'd come up with the same thing.
It would be, I think we're talking about 2 slightly different steps. This step is explain what you got, period. Not do any summing.
And that's what I was trying to ask earlier. Like, how do you very first find what it is?
I think it's important probably to do this way then, just because all you're doing is exposition, right? Explaining what you got.
And that's based on the CIDR, right?
Yes, the very first network that you take, then you
This
go
whole
from
thing.
there.
So can you do that in your head without doing it in binary?
Me?
Yeah,
Yeah.
you can. Because you memorized them, or because?
No, I pretty well look at the octet and go, okay, there's 3 bits that are gone.
Oh, yeah, I suppose.
You know what I mean?
Yeah.
I go, well, 11 has, that, I really probably would think, okay, 8 plus 3. I know the 3 is gone. Because that's the last two bits.
That's true. Okay.
But it has to be however it works for you.
Would you ever double check it with the binary if or do you?
I do once in a while, but 11's easy. Why do you think I put it down? Damn. I thought that would be the easy part.
I got everything else right. See?
Okay.
All the other numbers are right. I checked it. Oh, did you?
All right, so how many of you actually finished?
I did, but I got that wrong. I got it with a 10, but everything else is right.
All righty. So our real network is 172.21 here, 8.0/21. All right, let's stop any side discussions now. Let's walk through it. Now we know what we have, right? We also know that we start with the 500, right? And then the 200, and then what? 60 and 15. Oopsie.
And 2.
And 2.
Wait, how come sometimes the CIDR will change when you do that?
Meaning what? Your CIDR's always going to change.
Yeah.
No, it stayed the same,
Depending
no.
on the size of your network.
Oh, that's again just an explanation of what we have.
Right. Is that 20, could that CIDR
The
change?
21 will never be that. If I'm looking at the existing
Oh, okay.
network that I'm breaking up, that would never change.
I thought I remembered an instance where it changed.
Nope, it will never change. Any other questions about this? I mean, this is the setup, kind of, right? This is setting it up so that you can do the breaking of the network. So I've got this network. I might have this written down in binary. I mean, I would. Do what I say, not what I do. Right? I would write it in binary. If I were taking a test, I'd totally write it in binary. Why? And I'll tell you why. Because I asked that question. The whole point is, what if you get it wrong? You come and bring the test to me and show me the work. How many times has the teacher ever told you that? Right? Especially in math and stuff. If I can see the work, I can go, right, oops, here's where you went wrong. And if that happens, I'll say, go fix it. No penalty. If it's a simple math error, not a problem. If it's a concept error, then we're talking.
Plus, if you screw up on the first network, then everything after that's wrong too. Which hurts.
Exactly.
Well, but like me, all the last digits are right.
But
Don't take those all to be right.
it better be right. And don't use it, you cannot use an online calculator, you cannot use any kind of calculator in this test.
Fingers and toes?
Sure. See, in this crowd, you can count to 21. Now, it's not in your head though, write it down. And the more you write down the binary, the less likely this would be an egregious problem if you've got it wrong. Because you'd see the binary again and just write the correct answer. All right, so I only care about the last two octets. Is that an issue? Is that clear?
How high does the citer have to be before you start getting into the second octet?
Well, it's actually a low number,
Or, yeah, that's what I meant.
like 12.
Okay.
You know, then I'd have what, 4 in the second octet? This number really can be quite small. What if I have a 10? 10 now, that's a /8 in theory, right? And then I'd probably do a little bit into the next octet. That's quite possible. I would never give you something that has 4 million, hosts, at least on the test.
Yeah.
All right. Okay, so let's see, 128, 64, 32, 16, 8, 4, 2, 1. I'm just writing down my network address. 6, 7, 8. Right? That is 8.0. This part that I'm going to be stealing bits from. This doesn't change, so why write it down? Clear?
Yep.
If there's any detail, now is the time to ask. That is my network address, and where does my, let's see, it's 11 bits, right? For the hosts. 21 plus 11, 32. Keep that 32 number in your brain. If I make any references you don't dig, just let me know. So this is my network. Now, let's figure out how many host bits we need. For 500, how many host bits do I need for at least
9.
500? 9? Is that correct?
Yep.
And then 200?
8.
8. 60?
6.
And
5.
15?
5.
IQs. Anybody stumble into that?
Almost.
Because it's 16 minus 2 is 14. Right? And then 2. That's a gimme, right? The 2 hosts will always be 2 bits, and it'll always be a /30. You'll know that for sure. So, I have 9 host bits in my first network. I break up that network, it goes away. 8, 9.
Okay, now what if you needed, instead of 9, 8? Then you'd draw that line in the third. You'd have 3 digits there. That wouldn't do it doesn't change anything at all?
I mean, I would allocate, if that was an 8,
Yeah.
I would still have, okay, let's talk about what we have right now, for now. How many network bits do I have now? New network bits. 2. That gives me 4. That would actually be just fine in this example. If I had 3 new network bits, then that would be fine, and I just allocate 2 of those networks that size to those 2 networks. Right? It wouldn't really change anything in this example.
That was where I was getting confused at home.
Yeah, because in this case I have 0, 1, 2, and 3. In binary. Right? Do I need to write it down?